Today in lesson 31 we are going to multiply and divide rational expressions. Remember, rational expressions means that we are talking about multiplying fractions here. Alright, now there's lots of different ways to do these. The most important thing to pay attention to with this is you have to stay organized. Alright, and there's lots of different ways to do it. I would say most of the time, now I don't do this all the time, but most of the time I'm like, well, let me try and simplify my fractions here, my individual fractions. So if I look at this first one, I can say, well, the 6 and the 7 aren't going to change at all, so I can rewrite that. The A's, well, I don't have anything else there. But the B's, I've got 3 on top, 5 on bottom. That means I've got 2 left over on the bottom there. Makes it a little bit simpler. 21 and the 4, nothing simplifies there, so I'm going to rewrite that. I've got 1A on top and 5 on the bottom, so I end up with having 4 A's left over on the bottom, and then 4 B's on the top. Alright, now this, after you do that, that's not too bad. But after you do that, then it's really easy to start losing stuff here. So this is where you gotta be careful. Now, what you can do, you can deal with the numbers first because all of this stuff is being multiplied together. So I would go, well, here's a 7, there's a 21, one's on top, one's on bottom. I can simplify doing it that way too. So I've got, that turns into a 3. And then the 6 and the 4, well, 2 goes into both of those. So this 6 turns into a 3. This 4 turns into a 2. Can you see how this starts to become a mess here now? Alright, from there, simplify your A's. I've got 3 A's on top, 4 on bottom. Well, I just end up with 1 A left on the bottom. I've got 2 B's on bottom, 4 B's on top. These are going to go away. That turns into a 2. Now, as you can see here, now I've got a mess. So hopefully I was very, very careful as I go here so I know what's going on. 3 times 3 is 9. B squared over, I've got a 2 and an A. And that is that completely simplified. So this would be simplified. Alright, so then it says evaluate for A equals 3 and B equals 4. So I'm just going to throw those in. 9 times 16, because 4 squared is 16, over 2 times 3. Well, 9 times 16 is 144 over 6. Does 6 go into 144? I believe it goes in 24 times. So our answer for that then is 24. Alright, next one. Multiply and identify all values of x that make the expression undefined. Alright, now remember, as we talked about before, that undefined part, you have to find that first. Alright, but before I even do that at all, I've got a whole bunch of expressions here. I'm going to throw parentheses around it, every single one of these expressions, because remember, when I do that, that means that top and bottom have got to be exactly the same for me to cross anything off. Alright, and then from here, I am going to try and factor these down. So, I'm going to leave the top one alone for a second here. I'm going to come down here, x squared minus 9. Well, that's difference of 2 squares, so x plus 3, x minus 3. Coming over here, got a trinomial, x squared is x and x. Signs are the same, they're both minus signs. 6 would be 3 and 2 because those add up together to give us 5. On the bottom, same sort of thing. X and x, signs are the same, they're both minus. Alright, 25, well that's going to be 5 and 5 to give us 10 here. Alright, now coming back to the top left hand corner. Alright, all of you can see that, well, if I take an x out, I'm going to be left with 15 minus x. Does that matter in the grand scheme of things? No. What I was looking for was, well, maybe this would turn into, if I ran a -1, or I took a -1 out of this could turn into x minus 15. Maybe that simplifies with something else in the problem if we took that -1 out. It doesn't this time, so it's no big deal. Alright, now that we have everything factored though, now we need to find the values that make this undefined. So x cannot equal, remember how we do that, set each one of the factors equal to 0. So x plus 3, subtract 3, means we've got a -3. This one, add 3, means we've got a +3. This one, add 5, so that gives us a 5 there. And this one, add 5, so we've got a 5, we've already got that one, so we don't have to do that one again. And then from there, whenever it says multiply, yes, we multiplied them, but really what it's talking about, when you throw both of these equations, or both of these fractions into one, we want to simplify as far as we can. So that means this x minus 3 and x minus 3 go away. There's nothing else to simplify here though. So when we multiply these together, our top becomes x times 15 minus x times x minus 2 over x plus 3, x minus 5. Now you could put squared if you wanted to because we have 2 of these, or you could just write down another x minus 5. Both of them are correct. This is as far as you have to go though. You do not have to run that through. In fact, most people would appreciate it if you just left it like this because this tells us way more than if you multiplied everything together. Alright, so just leave your fraction in factored form. That is plenty good enough for what we're doing here. Okay, same thing. Alright, we are multiplying 3 of them now. No big deal. Our first step, put parentheses around everything. Alright, and then we need to see if we can factor things out. 3x plus 9, well we can take a 3 out of that. So x plus 3. Our bottom, that looks like a mess. Hopefully we can factor it. 5x squared is 5x and x. Alright, I'm going to come back to this in just a second because there might be a little shortcut that we can use as we go through here. If we come to our next one, 25x squared minus 1. That's a perfect square with a minus in between. That means we have difference of 2 squares here. So 5x plus 1 and 5x minus 1. Alright, the bottom, x plus 3, that doesn't change. Over here, the x plus 2 doesn't change at all. The bottom here, we can take out a 3. So then when we do that, we are down, this turns into a 5x plus 1. Now as you can see, this 5x plus 1 and that one cancel out. But we've still got this 5x over here, and what we have to do is we know the signs are different. We know the last numbers have to be a 1 and a 2, or a 2 and a 1. Now here's where I would use a little bit of common sense here. Most of the time when you do these, you're going to try and be simplifying these. Alright, well the 5x plus 1 cancel out already. My guess is that if we put a minus 1 here and a plus 2, this would cancel with that would cancel with that, so it would make things simpler. Let's see if it works. 10x minus 1x, there's our 9x. So that does work. That's why I saved that for the end, to see if I could get rid of some of the guess and check part of these problems. So then, now that we have everything done, our next step, what can x not equal? Set this equal to 0. Add 1, divide by 5, gives us 1/5. This one, subtract 2. This one, subtract 3. And this one, remember this 3 doesn't matter, there's no x out there, so it doesn't matter at all. This one here, subtract 1, divide by 5, would give us a negative 1/5. So all 4 of those x cannot equal, but then when we simplify, x plus 3's are gone, 5x plus 1 is gone, 5x minus 1 is gone, x plus 2 is gone. We are left with a 3 on top over 3. So this whole thing equals 1 as long as x doesn't equal any of those numbers there. Alright, lots of simplifying that can be done in some of these. Sometimes, just like the last one, there's not a whole lot that can be done. Other times you cross out pretty much the entire thing. Alright, and that's how we got left with a 1 here. Next one, we are doing still pretty much the same thing, alright, except we've got a divided by sign in there. Well, that's fine, your steps still pretty much stay the same here. Put parentheses around your expressions. Notice the 21 is not an expression, so I'm not going to put parentheses around that. But these two are. This one is not. That's just one term, so we're going to leave that. That's one term, and there's an expression. Alright, now we start to factor things out again. The top, 21, doesn't change. This one, trinomial, so x and x. Signs are different, so plus and minus. Let's see, to get a positive 1, that means we gotta have a positive 3 and a negative 2. Negative 2x plus 3x gives us the positive x there. Times, then for the next one, remember, first step is always to take out whatever you can. So we can take out a 2x, and then we're down to x plus 3. Remember, when you take this stuff out, that's like dividing. 2x squared divided by 2x leaves us an x. 6x divided by 2x leaves us a 3. The bottom here stays the same for now. Alright, now we come to this divide. Now you cannot divide fractions, but you can multiply by the reciprocal. So we are going to multiply this here. We're just going to flip this upside down. This x minus 2 can't be factored or anything, so that just stays there. And then the 1 goes down on the bottom. Now we can multiply them. Now we can do exactly what we did on the last page here. So, first step is, well, x cannot equal negative 3, positive 2. Oh, and this could be a mess here, couldn't it? Because we've got 2 variables in there. Alright, the easiest thing to say is because of this, well, if we solve this for x, say we just ignored the y was anything else but 0, well then x can't be 0 here. And then, if you look at this from the y perspective, if we say x is any number but 0, well then y can't equal 0. So there are our excluded values, and then we just simplify our expression. X plus 3, x minus 2, x minus 2. Alright, from here, you could do one of two things. You could try and stay organized, so multiply these together. Alright, and then 42 divided by 3 is 14. Alright, 1x on top, 3 on bottom, so that means we've got an x squared on the bottom with a y. You could also do it this way too. You could say, well, 3 and 21, that becomes a 7, this becomes a 1. Get rid of the x here. That means we've got 2 left over, so we still end up with 14 over x squared y. Alright, so either way works. It's kind of up to you at that point how you want to do it. Alright, next one. Word problem. A packing company designs 2 storage boxes. The volume of one box is given by B1 equals 20h cubed. Volume of the other box is given by B2 equals 14h squared W, where h is the height and W is the width. The boxes need to have the same volume and height. What must be the width of the second box in terms of its height? So, what must be the width? That means we need to solve for width here. But an important thing is, the boxes need to have the same volume. Alright, so we know that the volume of the first box equals 20 h cubed, volume of the second box equals 14 h squared w. Now, because they have to have the same volume, we can set these equal to each other. And then, all we need to do is we need to solve for w here. So we're dividing both sides by 14 h squared to get this down to w on this side. H squared cancels with that, so we've only got one h left. 20 and 14, well, a 2 goes into both of those. It's 10 and 7. So it looks like we've got 10h over 7 is what the w needs to stand for. Alright, last thing you need to look for is you need to look to see if you have a label anywhere. I don't see any. So w would equal 10 times h over 7 units. And we are, for width, we are just talking about distance, so it's not a units squared or anything like that. It's just a w here. Alright, stay organized with these. Be very, very careful, especially with your exponents for your variables. And any questions, please let us know.